So quick recap. We're going to now move from graphing quadratics into solving quadratics. The first method we're going to look at is by taking the square root. Um, if you notice, a lot of these quadratics have some kind of x squared term, right? Ax squared plus bx plus c. Here's x squared. Or we had the a times x minus h squared plus k. Here's this squared term, right? And to undo that squaring, we have to take a square root. Again, the big idea here is we're trying to end up uh, you know solving for x, right? We want to solve for x, just like you've been doing for a long time. But in order to do that, at some point along the way, like we see with these two examples, there's going to be some kind of squared term. So first off, consider when you just did x squared equals 16. Well, if I need to solve for x here, how do I undo squared? Well, that means we need to take the square root. So we have x squared equals 16. So if we take the square root of both sides, then the squared and the square root cancel each other, and we're left with x on the left side. And then when you take the square root of something, you have to remember to do plus or minus 4, right? Because if you think about it, not only is 4 times 4, right, 4 squared equals 16, but also negative 4 times negative 4 is 16. So some steps along the way just to make sure you do this right. The first thing you want to make sure you do is isolate the squared part. Now, sometimes the squared part will just be x squared. Sometimes you'll have like x minus some kind of number squared. Anything that's squared, you want to make sure that we isolate that. We get any numbers, anything that's been multiplied or added or subtracted away from that, right? And when you take the square root of both sides, remember to do plus or minus. And then once you've got a radical, let's go ahead and make sure we simplify them all the way. So we start here. Take x squared equals 25. And we're going to take the square root of both sides, right? And there, again, the squared and the square root cancel each other. We're left with x equals 5. But remember, back here, step number 3 says, go ahead and get used to this. Every time you take a square root, remember to do plus or minus. Here, we take the square root of both sides. So that leaves us with x on the left side. And we know the square root of 36 is 6. We have our plus or minus. But this is one of those, remember to use I when it's necessary. When there's a negative under the square root, like you see right there, you always put I. All right, here's one where we're going to have to do some work before we can take the square root. So go through this just like you would any algebra problem. Add 12 to both sides. So that leaves us with 5x squared equals 200. Now to divide both sides by 5. Now we've got x squared equals 40. So what I'm going to do is I'm going to take this problem up here. And it's at this point that I can now take the square root of both sides. So on the left side, I'm left with x. On the right side, we've got plus or minus. Now, 40 can be broken down, right? If we take a moment, maybe I give myself a little bit more space here. So 40 would be 4 and 10. So we have 2, 2, 2, 5, which means I can pull out a 2. And I'm left with a 10 underneath. So x equals 2 root 10. But remember, since we took this square root right here that I'm putting the arrows on, I have to do plus or minus 2 root 10. Here, we're going to have to divide by 1/2. This is just a, make sure you do this carefully. We can't distribute the 1/2 because of this squared out here. Again, we're trying to solve for x, so we just need to start moving stuff away from the x. The first thing we need to move is that 1/2. Divide by 1/2. Be very careful here. We're left with x minus 3 squared. 5 divided by 1/2 is actually 10. So now we've got this squared part isolated. There's nothing in front of this. There's nothing being added or subtracted back here. So we can go ahead and take the square root. So if we do x minus 3 squared, if we take the square root of that, we're left with x minus 3. And then we're going to take the square root of 10. So that leaves us with plus or minus square root of 10. And then one more step here. So here's x minus 3 equals plus or minus square root of 10. We need to move this 3 over by adding 3. So again, the big objective here, we're just trying to solve for x. So we end up with x equals 3 plus root 10, or you have x equals 3 minus square root of 10. You have the plus or the minus. That's what that symbol right there means. It means there's two possible solutions. Let's try another one. Divide both sides by negative 2. We want to get the squared part. The x minus 3 is what is squared all by itself. So with x minus 3, quantity squared equals 4 divided by negative 2 is negative 2. Now we can take the square root of both sides. I'm going to take the square root of x minus 3 squared. We end up with just x minus 3. And here we end up with plus or minus square root of negative 2. Now, we cannot simplify negative 2. However, or the 2, we can pull out an I. So we can go to this point right here, plus or minus I square root of 2. And then we can move this 3 over, add 3 to both sides. So x equals 3 plus I square root of 2, or 3 minus I root 2. So those are my two options for x. Here, just divide both sides by 5. So we're left with x squared equals 20. Now it's time we can take the square root of x squared. That is equal to x. We take the square root of 20, and that's equal to plus or minus root 20. We'll now break 20 down. We have 4 times 5. So I can pull out a 2. So x equals plus or minus 2 root 5. All right. We'll do a couple more examples. Take the square root of both sides right here. So I'm left with x equals plus or minus square root of 60. Let's break 60 down. 2 and 30. We have 2 and 15. 3 and 5. So I can pull out the 2. So x equals plus or minus 2 root 15. Here we can divide both sides by 5. So we're left with x squared equals 13. And when I take the square root of both sides, the x squared turns into x, and the root 13 turns into plus or minus 13, and I cannot simplify 13 any further. Here we're going to do some work. We got to get this x squared by itself. So first thing I'm going to do, let's subtract 18 from both sides. That leaves me with 2x squared equals negative 6. Divide both sides by 2, and now we have x squared equals negative 3. So now I can go through the process of taking the square root of both sides. So square root of x squared turns into x. This turns into plus or minus. 3 can't simplify it anywhere, but we can pull out the I because it's a negative 3 under the square root. Here, let's just go ahead and square root of x squared is x. The square root of negative 88. Well, so we have plus or minus. We can pull out the I, and we have 88 underneath there. So let's break it down. 88 is 8 times 11. We have 2 times 4, 2 times 2. So I can pull out a 2. So we end up with x equals plus or minus. So I pulled out a 2, pulled out an I, and what was left was that 2 and that 11. So that would leave me with 22 under the square root sign. Oh, excuse me. So there's your final answer to number 4. Number 5, the x minus 2. Here's what is squared right here, the x minus 2. There's what we want to get by itself. So we want to get everything else away from that. First thing I'm going to move is the 18. Subtract 18 to both sides. So we end up with negative 8 equals 4 times x minus 2 quantity squared. Divide both sides by 4. So we end up with negative 2 equals x minus 2 quantity squared. Now to do all the squaring, I'm going to do that. I just like having that squared on the left side. I don't know why. That's just kind of my thought. So let's take the square root of both sides. So the square root of x minus 2 squared is just x minus 2. And then we have plus or minus. So you got the negative 2. Remember to pull the I out. And now I'll add 2 to both sides. So here, again, because we have the two things, I like to just kind of write them out separately. Or 2 minus I root 2. There are two possible solutions. Here we just divide both sides by 5. So I end up with, let me give myself some separation, x plus 1 quantity squared equals 16. Now, let's take the square root of x plus 1 squared. That's x plus 1. Let's take the square root of 16. That's plus or minus 4. Don't forget the plus or minus, especially all of a sudden when we get these perfect squares. So far on this page, if you look back, we've had root 60. We could pull some stuff out, but there's still something left. We've had root 13, can't simplify. Root 3, can't simplify. Root 22, can't simplify. Root 2, can't simplify. But here we've got square root of 16. We can simplify that to 4. So we have plus or minus 4. So when I subtract 1 from both sides, I end up with x equals negative 1 plus 4, or negative 1 minus 4. Here, there's two possible solutions. So in other words, negative 1 plus 4 is 3. Negative 1 minus 4 is negative 5. So there's two possible solutions to this particular problem. So here, x can equal 3 or negative 5. Number 7, if we divide both sides by 1/3, if we're very, very careful with this, x plus 4 squared, and then we do 12 divided by 1/3 turns into 36. Now when we take the square root again, 36 is one we know. That's going to turn into plus or minus 6. This turns into x plus 4. Now x is going to be equal to, when we subtract 4 from both sides, we end up with negative 4 plus 6 or negative 4 minus 6. So x could be 2 or negative 10. And one more problem here. Number 8, we'll divide both sides by 4, so we end up with 3 equals x minus 1 quantity squared. Now let's take the x minus 1 squared, take the square root of that, and it turns into x minus 1. We take the 3, we take the square root of that, and that turns into plus or minus root 3. And now we got to add 1 to both sides. So here x equals 1 plus or minus square root of 3. I could have also written that as x equals 1 plus square root of 3 or 1 minus square root of 3. These are really saying the exact same thing.